Hey everyone, Geophysicist Stefan Burns here with a breaking update for you. We just observed a very rare burst of energy in the Schumann Resonances, Earth's naturally resonant energy fields, which are created from a variety of geophysical processes, primarily lightning strikes, but they're also created within our body, specifically our brain waves, perfectly overlap with Schumann Resonances in frequency and in strength. And what is so bizarre about this burst of energy here is that it occurred just hours before the absolute closest approach of Interstellar Object 3I Atlas to Earth. The separation distance between 3I Atlas and the Earth was just 1.8 astronomical units. Distance from Sun to Earth is 1. So that was at 6 a.m. Universal Time, December 19th. It just occurred less than 24 hours ago as I'm recording this video, and this occurred at 2:40 a.m. Universal Time. So 3 hours and 20 minutes before that exact closest approach. So it's right there, folks. Boom, we get this 25 hertz signal to pop off. You'll notice that it's not a bleed of frequencies. It's not broadband signal. It's a very precise signal going from about 24 to 26 hertz. And that's also very important as it relates to some of the observational data that we have regarding Schumann resonances, because we often see these pre-earthquake signals in the Schumann resonances from 24 to 26 hertz. Very specifically, what happens is that sometimes before high magnitude earthquakes, we observe these anomalous bursts of activity. It can be hours before, it can be days before, sometimes a little bit more than like a week, but typically it's like less than a week. If we get something like this, and that is a pre-earthquake signal, then we get the high magnitude earthquake. So this just happened recently. In fact, on December 6th, we saw a burst of energy in the Schumann resonances, the first anomalous one that we had seen in months. There's a lot of atmospheric activity, local in nature, that appears on these spectrograms. You have to be able to differentiate the signals. That was on December 6th, and then less than 48 hours later, we had that magnitude 7.6 earthquake strike Japan. So we have Interstellar Object coming in from a completely different part of the galaxy at its closest approach to Earth. Boom, we get this very narrow frequency signal at 25 hertz in the Schumann resonances, which we are resonating with ourselves, and that's also connected to earthquake activity at times. So a lot to cover in today's video. We're going to fly through it so you can get the download. Let's get right into it. So before I show you some more examples of pre-earthquake signals that we have observed in the Schumann resonances just over the past couple years, and also discuss our current seismic situation here on Earth and also the space weather situation, let's just learn what Schumann resonances are quickly. So they are these frequencies of light. This is electromagnetic radiation, magnetic fields, electric fields that exist on Earth globally due to a variety of geophysical forces and factors. So we have what's known as the global electric circuit, the flow of energy across the planet. Of course, we have a magnetic field, but we also have an ionosphere, as you can see denoted here. We have these lightning strikes that are occurring all around the globe all the time, about 50 per second. And a lightning strike is a bolt of plasma that generates frequencies across the entire light spectrum. So you see, of course, the flash of light, that's visible light. They also produce even up to gamma rays, but they also produce light in the lower frequency range, radio microwave, and even down to near 0 hertz, which is where the Schumann resonances are. The primary Schumann resonances, which are always vibrating at a higher power than nearby frequencies, are 7.8 hertz, 14 hertz for mode 2, 20 hertz for mode 3, 25, 26 hertz for mode 4, 33 hertz, 39 hertz, 45 hertz. They decrease in power as you go up in frequency. The foundational mode at 7.8 to 8 hertz. There's a bit of a range on them, about 1 hertz, is the strongest. About 70% of the energy is contained within mode 1. So mode 4 is a weaker Schumann resonance, but that is the specific Schumann resonance that's connected to pre-earthquake activity. We often observe these sort of anomalous bursts in mode 4 before high magnitude earthquakes. And the data suggests that's often before land-based high magnitude earthquakes, or if it is an earthquake based in the ocean, it has to be a really big one, because these signals are electromagnetic and the ocean's very conductive. So it'll absorb typically that energy before it can reach a sensor. Also, if you see a burst of energy in the Schumann resonances in a sensor, it's going to be fairly close to that location. So you have to keep that in mind too, because there is a decay to that energy as it propagates out. So this data that we've been seeing out of Tomsk, Russia, the space observing system, that is located close to Kamchatka, where we had the magnitude 8.8 megaquake this year, July 29th, and also fairly close to Japan. So those are the two main zones I'd be looking at right now if this is connected to earthquake activity, made all the more bizarre by the fact that it occurred just hours before the closest approach of 3I Atlas. So effectively the exact same time 3I Atlas is right there as absolute closest, we get this very rare burst of energy in the Schumann resonances, and we haven't been seeing them that frequently this year, though we do have a lot of observational evidence across time. But let's look at some recent examples of these pre-earthquake signals and then the earthquakes that followed them. So here we have the most recent anomalous burst of energy in the Schumann resonances that is not due to local atmospheric activity, because what we're looking at here is the vertical electric field. They put out this antenna and it measures the vibrations on that vertical electric field current going from the ground to the ionosphere. And so you have this natural flow of energy and there's these little vibrations that sit on top of it. Those are the Schumann resonances. We see them going across there. This is our frequency y-axis, 0 to 40 hertz. And you see that they have a higher power. Here's our power legend, right? Higher power than the other nearby frequencies. Like, for example, 10 hertz isn't high power compared to mode 1 at 7.8 to 8 hertz. Mode 2 shows up nicely. Mode 3, mode 4, mode 5. Here is that anomalous burst that occurred on December 6th. So we see that right there, the very end of December 6th universal time. And this one was not necessarily in that pre-earthquake range at its highest power. So this was a little anomalous in that regard, though we do see its frequency bleeding down into that pre-earthquake signal range of 15 to 35 hertz. But it was really centered there at 7.8 hertz and lower in that geomagnetic pulsation range. But that occurred less than 48 hours before the magnitude 7.6 earthquake struck Japan on December 8th. And that's the first anomalous burst of energy we've seen in the Schumann resonances in months. And I noted that in this post on Twitter, saying, hey, I don't know exactly what to make of this, but this is quite bizarre. And we had been having a lot of solar activity at this time, a very long duration 8.1 M-class solar flare, and also that magnitude 7 earthquake in Alaska that occurred just before the 7.6 in Japan. And so I wanted to report on it. And then, well, we had the big 7.6. And that area has been very active. We'll talk about that more in a little bit, but let's look at another example of pre-earthquake energy showing up in the Schumann resonances going back to 2023. Here we have two more data sets from the same space observing system out of Tomsk, Russia, and this is going back to February of 2023, and I have a whole story to share with this as well. I've shared it before. So here we have February 2nd, and we see these very unusual energy structures appear in the Schumann resonances, same scale and everything, 0 to 40 hertz. So we have them kind of reflecting across the frequency range there. And I noticed that when it happened, I was like, that's very odd. I've never seen that before. But I was still learning about this earthquake connection. So I didn't know immediately at that moment in time that, hey, we should be on high alert. But I did notice that they were quite bizarre. Then we had the magnitude 7.8 earthquake that struck Turkey in Syria on the 6th of February, right during the full moon. And here we see the time of that earthquake is actually a 7.8 and a 7.5 double earthquake sequence. These are the strongest earthquakes that we'd had since the megaquake in 2021, August of 2021. And we see that we also saw similar energy bursts in the Schumann resonances exactly during that rupture and continuing on for about 8 hours afterwards. So here you see it reflected in the lower frequencies. There we have it in that pre-earthquake range. And then again, also though much lower power density there in the higher frequencies. So really clear example, and some more data that shows this is that the quality factors went really high. The quality factor is a measure of the resonating system, the amount of energy within it and the amount of energy that's leaving the system. And resonance is really that building effect, right? So you take two tuning forks, same frequency, hit one, the other one starts to vibrate and resonate. And what's the damping on a system? So if you have that tuning fork, let's say swaddled with like cloth, it's not going to be able to hold that resonance. But if it's very low damping, so there's not much friction, you could say, right? It's going to resonate very nicely. You just put a little bit of energy in. If the energy loss is less, it's going to build and build and build. Resonance amplification. Q factor tells you whether resonance amplification is occurring or not. And we saw huge spikes in the Q factor in that pre-earthquake range, 15 to 35 hertz, with these signals there on the second and also the day of. But really clearly, 4 days before, Q factor went to 250. Normally it's like less than 20. That's for mode 3 at 20 hertz. And then it went to 59 here for mode 4 at 25, 26 hertz. So this was very clearly a pre-earthquake signal. We observed that, and then we saw the actual earthquake occur, and we saw very similar energy signals happen right as that earthquake ruptured, and then continuing on for like 8 hours afterwards. So this is a very key piece of data from recent in time. And of course, we have the December data that I just showed you for the magnitude 7.6 in Japan. There's other data sets I could show you from over the past couple years, but now we have this new earthquake burst exactly in that pre-earthquake zone that is connected perfectly in time to the closest approach of 3i Atlas. You literally can't make this stuff up. Now, maybe nothing comes of this, and we really hope that is the case, but we are right now in a pretty delicate situation because there has been a lot of activity in Japan, and it looks pretty anomalous and could even be foreshock activity. And if that is the case, then we could be building up to a very big earthquake. It's certainly possible. So here we have the earthquakes forming in Japan going from the 1st of November through December 13th. You'll see that there are two distinct zones here. This was the zone that first popped off, characterized with the highest magnitudes 6.4 and 6.8 earthquakes. And that was early November. And then zone 2 is what's recently been active with that 7.6. And I have this compared to the earthquake activity that occurred before the 9.1 magnitude Great Tohoku earthquake, March 11th of 2011, because there was foreshock activity there, which was unusual. And this zone right there, when it started popping off in November, was basically a mirror to that. Very interesting. And then zone 2 came up, and well, now it's really anomalous. So this could be all she wrote. Maybe this is it. But that area, you know, the 9.1 was roughly here. This whole area has been very active geologically now in the geologic time frame of 15 years. It's a short time frame for geology, so and geologic processes. So this whole area could be due to release more energy. So we looked at the buildup of activity between zone 1 and zone 2, and then we compared that also combined to the magnitude 9.1, and we see that there was 3 times more energy release during this sequence of activity here than there was in the week leading up to the magnitude 9.1. The key difference is that this is 6 weeks of data, that's 1 week of data, but if we are building up to a bigger event, then you expect that to have activity over a longer time duration. And I can't say that this is in any way definitive, but if the energy scaling ratio holds for the foreshock activity to the main shock, then this recent activity off the coast of Japan could indicate a magnitude 9.4 earthquake occurring in the near future. I don't know if that is an earthquake scaling ratio that exists, but based off of the foreshock activity before the 9.1, what's happening right now, I think it could be a useful measure, or at least give us a sense of what is possible, and that there's a higher possibility of that occurring in the near future. And there are some space weather factors that are active right now, and also some planetary alignments which are active starting right about now, which are worth considering. We'll talk about them, but before we do that, let us also look at our longer kind of time frame for earthquake energy release and the state of the globe seismically. So here we have global seismic energy release measured in gigawatt hours. This is a log scale there. And also major earthquake counts going from 1900 to 2025 based off official USGS data. And because these are magnitude 7.5 earthquakes or greater, it's very unlikely that we've missed any earthquakes here in the earlier count when we had less seismic density with our stations, because the magnitude 7.5 is picked up basically everywhere around the globe. So we see 1906 was a significant year. There was no magnitude 9 earthquakes that occurred that year. There was an 8.8. but we see that's one of the strongest years ever in terms of seismic energy release. And here we see the years with magnitude 9 or greater earthquakes. So 1952 was the magnitude 9 off of Kamchatka. Then we have 1960 there with South America, the big 9.5, Alaska 9.2. Here's the 9.0 Sumatra and 9.1 Japan. This is 2025. This is this year. We're not even done with the year yet. And this is the strongest year in terms of global seismic energy release, except for these magnitude 9 plus years and also 1906, which had like so many magnitude 8s and 7s. It's ridiculous. It's a crazy year. So we're ready in a very active year seismically. And the way this kind of works is that each earthquake, as it ruptures, spreads energy out across the globe. And some of that does get loaded into other fault systems. So a big earthquake will rupture and the faults and the plate boundaries immediately adjacent to it will have stress taken off of them. That's the earthquake shadow. But outside that shadow, they're going to have load placed upon them. So we had the magnitude 8.8 in Kamchatka, plus multiple Mag 7s and tons of Mag 6s and 5s, of course. The earthquake shadow for that would be the island arc north of Japan, and then also part of the Aleutian Island arc with Alaska. But Japan itself, and that subduction zone, is going to be outside that earthquake shadow. It's been loaded now with a ton of energy from those quakes. And you'll notice that 1960 here, this magnitude 9.5, that occurred South America. Look at how much more energy release in terms of gigawatt hours, like the actual measure of energy. This is logarithmic. So if there is a balancing effect across the ring of fire in terms of global seismic energy release, because the plate moves this much there, it needs to move that much to a corresponding section across geologic time, this 9.1 Japan is not sufficient. This, in addition to, let's say, what occurred there, 9.0 Kamchatka, 1952, and also 8.8 this year, 2025. That still pales in comparison to the amount of energy release from that 9.5 in South America, from that subduction zone. So if that is the case, then we certainly could be due for a bigger earthquake in that region of the globe, Japan, Kamchatka, because this is balancing out the plate movement and the energy on a longer geologic time scale. So very interesting stuff. This year has already been very, very seismically active. And a key factor to that is the space weather activity that we have been having. We've been having a ton of these coronal holes on the sun this year and also starting last year. This coronal hole in particular has been on the sun now for many rotations. It takes about 28 days for the sun to rotate at the equator. And so this has been showing up time and time again, about every single month. And what happens is that when these coronal holes reach the geoeffective position right there, we have a specific type of space weather. They are areas in the solar corona, the outer atmosphere of the sun, where the density is low and there's lower plasma temperature overall. The solar corona typically is very, very hot, millions of degrees Kelvin, and it has all this plasma there. So effectively there's very low plasma there. Why? It's because there's a magnetic field that extends out from the sun deep into interplanetary space. Earth is at 1 astronomical unit. We're very close to the sun. These very special magnetic field structures, they connect to the Earth. So when we connect to that coronal hole high-speed stream, we're directly connected to the magnetic field of the sun. High velocity solar wind is flowing by us and the solar wind density drops. So we just had one sweet bias right there, as you can see. Solar wind velocity right now is actually quite high. The density is fairly low. But this one in particular has been linked up with earthquake activity now for basically 6 months. And all the big earthquakes have effectively happened during that coronal hole high-speed stream impact after the main burst of velocity increase, and then when the solar wind density goes down, because that really seems to be a key factor. The energetic environment around the Earth as a whole seems to have an influence on plate tectonics, and we also see that this is an energy loading influence onto the Earth. This coronal hole is transequatorial, meaning that that magnetic field and the high-speed stream will sweep by the Earth, whereas if it was up here or down there, it could kind of go, below or above. So it's transequatorial. That's a very important component. It's wide, meaning that we're in that for a while, whereas this one's narrow. We're kind of just in it for a little bit. This guy, we're deeply embedded in it for more than a day, 2 days, 3 days. and it's also negative polarity, which is the polarity you need to connect to Earth's magnetic field. So this has been a perfect coronal hole, you could say, for triggering earthquake activity, and that's what we've seen, so let's check it out. Here we have our global seismic activity level for 2025 as provided by Volcano Discovery. Link to this and all the data shown in the video description. And we want to look here at the periodicity in high magnitude earthquake activity. So we have different levels. We have low, moderate, high, very high, and extreme. Here we see that magnitude 8.8 earthquake that struck Kamchatka. And we see that there's actually a seismic burst that occurred around that time, going from the middle of July up to the very beginning of August. Well, look at the next earthquake that occurred there. This is south of South America in the Drake Passage. There's been an antipodal sequence between Kamchatka and Drake Passage, which has been very interesting. But then you'll notice you go back here, we get another big earthquake, Kamchatka, then we move over, we have this 6.4, 6.8 earthquake sequence, Japan, that was early November, and here's the latest 7.6 in Japan. Look, that's basically 28 days in between these. If you do the calculations, it matches that solar rotation period. There's a little bit of variance, a little bit of wiggle room. Nature isn't perfect, but we do see this periodicity very clearly displayed with our highest levels of seismic activity for the past 6 months. And remember how earthquake energy scales. It's like exponential. So you go from magnitude 6 to magnitude 7, that's 32 times more energy. So all this activity here is very low energy compared to what happened here. Same with there to there. So this is very significant. And guess what? These periods of time are when we were in that coronal hole high-speed stream, and specifically slightly afterwards when the solar wind density was severely depleted below 1 particle per cubic centimeter, or at least there was a zone of that for a longer duration. And like, for example, here we had our solar wind density elevated quite high for a longer period of time. And in fact, it's right here at the 6.4 and 6.8 that it dropped below that 1 particle per cubic centimeter threshold for a little bit, and then we had that burst, which is the biggest during this entire time frame. So there's a clear connection between the space weather right now and the Earth terrestrial environment and global activity in terms of earthquakes and seismic energy release. And we have that coronal hole high-speed stream coming up once again, with this one soon to be geo-effective in about a week's time. So the end of December going into beginning of January is the critical time frame that we're looking at for that effect to take place. We just had this anomalous burst of energy in the Schumann Resonances, which is quite bizarre. It's not normal. We do not see these that often. So this is something definitely pay attention to. It's basically like a canary in the coal mine. It's not guaranteed to result in anything, but it's definitely worth paying attention to. And in addition to all this, we have this historic planetary geometry that is coming up early January. So you put all these factors together and wow, we really got something. I mean, we have this earthquake, pre-earthquake signal that occurred during the closest approach of 3i Atlas. And then here, look, January 6th, January 7th, January 8th and 9th, we have this alignment with Jupiter, Earth, Mercury, Venus, and Mars. This synodic cycle where Venus and Mercury are on the other side of the sun, that occurs once every 6.6 years or so, 2,338 days. Sometimes Mercury participates, sometimes it doesn't, but in general, it's so close to the sun, that's kind of always there, right? An outer planet combining with this is quite rare. So last time we saw this sort of synodic cycle was actually 1936. We can go back to that here, and that was quite interesting. We did not see, as far as I know, some sort of big event for that, but of course that's right before we had World War II. So I think that's also significant. But here we see that there in 1936, but it's also not as precise. So what we have coming up now is more precise at the angle. And if we go back to one more historic example, which is interesting, we go back to the Carrington event. And what you'll notice is that in 1859, with the Carrington event, we had that alignment just a couple days before that massive solar flare. So we can go here and we'll see this planetary alignment form. And look at that, you'll see Saturn participating. So when we get these sort of outer planet configurations with this normal synodic rhythm of Mars, Venus, and Earth, things seem to happen. So this is going back right there to late August, and then September 3rd is when we had that big solar flare or multiple flares that Carrington observed, which then gave the Earth a big space weather wallop. So there are multiple factors at play right now. I will keep you up to date on all of them. That is my job, my duty. So please subscribe to the channel to stay up to date with what is happening here on Earth energetically. Also, what's happening with the sun, space weather, planetary resonances, interstellar objects, three-eye atlas, comets, everything. We cover it, videos almost daily. Thank you all so much for watching. Please smash that thumbs up button to help this channel grow. Again, I've been your host, Stefan Burns, wishing each and every single one of you well. Please take care of yourselves. Have a wonderful Christmas, happy holidays, and I'll see you all very, very soon.